Okay. So, yeah, I'll repeat it in case somebody didn't hear it or didn't have their headphones in, whatever. So yes, tomorrow is the first Flex Friday we're having this trimester. And so what that means is tomorrow at 8:35, you guys, or you'll stay home regardless. You don't come to school tomorrow. But tomorrow morning you have advisory at 8:35. Your first normal class is at 9. So it's the same schedule it was before, but in case you forgot. First hour is at 9, second hour is at 10, third hour is at 11. And then we don't have a split lunch because lunch is after your classes. Okay, so this topic itself, um, how should I put this? I think if everything goes well, we're going to do our notes and you guys will be done with the homework before lunch. Like, that's kind of my goal. It might not happen, but that's my goal. And then after lunch, we're going to do something that I haven't put in the folder yet. Partially because some of you guys have. There's nothing wrong with working ahead, but some of you guys like to do the work while we're doing it without even knowing how to do stuff. And so I end up just kind of correcting stuff that's not even along the right lines. So after lunch, we're going to be doing something else. It's not necessarily hard or new or whatever, but it's just different. So this is kind of our goal before lunch. And I think this shouldn't go too bad because it's kind of similar to what we did before. So what I will start with, come on, there we go. If you see the word solving, the word solving is when your quadratic is equal to 0. Now, we did technically do this before with factoring. This is going to be along the same... Oh, thank you, Luke. I'm out of it. I was giving a test the last 2 hours, and so I haven't... I've just been staring at Google Meet faces all day. Yes, sharing my screen would probably make it a lot easier for you guys to learn. Ooh, it's going really slow. Did it share the screen with you guys yet? I think my browser crashed. Yeah. Swell. Okay, I gotta close the browser and open it back up. All right, there we go. Okay, so solving quadratics by graphing. What I was trying to explain, which I was pointing to but you couldn't see it, is that the word solving there means when your quadratic is equal to 0. So that's what we're trying to be doing here. So if we're going to try to find out when the quadratic is equal to 0 by graphing, this means when the height of the graph is 0. We kind of talked about these the other days, 2 days ago I think it was, when we were talking about axis of symmetry. because we purposely had the x-intercepts when we were trying to do stuff for the axis of symmetry. So that's actually what we're trying to do for this section, is we're trying to find out where the x-intercepts are, because that's going to be our answers. And then before we do too much, yesterday we did transformation graphing. And I don't know how that went for you guys. When I asked, some of you said that it felt like it went really well, and some of you felt like it was kind of iffy. And so I don't know how you feel about it after the homework. But there's basically two styles of graphing. Let me shut off my phone. Transformation graphing can only have the two numbers. That multiplier on the x squared and the number being added subtracted. I should have written this as a C instead of a B. Maybe I will. It doesn't matter if you do or not. It'll just bug me. What I'm trying to point out is that. So there's different ways quadratic equations can look. Like, it depends on what terms are there. And I don't know if you noticed it or not, but when we did transformation graphing yesterday, there was no middle term. There wasn't like a regular x. So transformation graphing, probably, my guess is you thought it felt easier. Maybe not. But the other graphing method that we're going to have to do is super annoying, because you have to find the vertex by using the axis of symmetry. Then you have to graph. This is what we did 2-3 days ago. You have to find the vertex, then you have to graph some random points, and then draw the mirror images. That it doesn't really have a name. Like, it's a method, but it doesn't have a name. So I just kind of call it the slow method. You have to use that method if there's an x term. So I guess what I was hoping to get from you guys is I wanted to find out what you guys thought of yesterday's method of graphing. Because if you found transformation graphing difficult, then I'm not even going to talk about it today. I'm just going to do all of them the slow method. If you thought transformation graphing wasn't bad, well, then I'll definitely do both, because transformation graphing goes faster. Could you guys put in the chat how you feel about yesterday's homework after you were done with it? 0 to 5? Because then, that kind of lets me know how I should teach you today's. Because if something wasn't working for you, then it's kind of dumb for me to use it. Okay. I think I will use it today then, and then who knows, maybe seeing it again might help you if you're you know, if you're 3, 4, or whatever, you know, not out of 5. Sure. Okay. Well, then the first one we're going to try to solve is y equals 2x squared minus 2 equal to 0. It's not going to say y equals, because when you're asked to solve it, it'll say equals 0. But in your head, you should kind of know that it means y equals. Can you guys actually sit there and focus on your own info? I'm not a fan that you guys have had a different person in there all the time. Number one, it makes it difficult for that other person. Number two, it makes you feel as if I don't recognize what's going on. So we're gonna graph this. Because there's no middle x term, I'm going to be able to graph this one the faster way. So the minus 2. AJ, do you remember what the minus 2 at the end does? What does it do to the graph? Okay, perfect. So the vertex moves down 2. So the vertex is kind of like our starting point, because the tip of the U is the easiest place to graph. So I'm going to move down 2, and I'm going to put a point. This multiplier of 2 in the front is twice as tall. Now you don't have to draw this next part. I'm just reminding you how to do twice as tall. A normal parabola is over 1 up 1, over 2 up 4. That's a normal parabola. Twice as tall means I'm going to go, instead of going up 2, I go up 4. Instead of going up 4, I go up 8. And then I draw the mirror images. Now I will tell you guys today that the equations that are picked for you purposely are picked so that they cross at nice spots. So don't worry about the equation working out weird. So the equations that you guys have are purposely picked. Desmond, do you think you could help me answer this question then? So this is what we were trying to do from the start. Equal to 0 is the x-intercepts. Where is this graph equal to 0? I get what you're trying to say. I'm trying to think of how to phrase the question so that it makes more sense. Where does the graph cross the x-axis? Is that better? So, yeah, that's what I was asking for. That's perfect. So it crosses right here and right here. So those are my two answers. Let's see. Ava, are you in the classroom? Or are you at home? Does anybody, I don't know, does anybody know Ava? Is she in the room? That's really all I need to know. Do you guys know her? All right, Ava, if you can hear me, send me a message or something, if nothing. Before I go on, I know I got off on a tangent there. Does somebody want to ask me questions about this graphing, like from yesterday? So obviously I kind of, tried to highlight this, what the answers were. Ooh, I made a, you know what? I should have done this better. I made Rudolph. Oh, actually, that's like an evil Rudolph. Back up. I should have done this more intelligently. Now we've got Rudolph. How do we get brown? We need a brown one. Is there a brown marker? We got gold. That works. Copper. Now it's more like Rudolph. There you go. Oh, shoot. I put it different. Okay, now the second example is going to be like one of the ones we did a handful of days ago, where you can't graph it with transformation graphic. Negative x squared minus 4x minus 4. Okay, because it has middle term, we have to do it the long way. The long way means I need to identify A, B, and C. If you need a refresher, A is the number on the x squared, B is the number on x, C is the number by itself. The axis of symmetry is negative b over 2a. And I know you guys have it written down in your notes. I just didn't. I didn't think many people would remember this off the top of their heads, so I just kind of did it. So the opposite of b is the opposite of negative 4 over double negative 1. So this is 4 divided by negative 2, which is negative 2. So that tells me my parabola is centered here. So this is the axis of symmetry. I'm pretty, I think I called on Jack for this question every time now. So this means you should be an expert at this, Jack. Do you know what I'm going to ask next? Perfect. Okay, so what's the answer? Good. Very good. I'm going to plug negative 2 in place of x. So the negative of positive 4, negative 4 times negative 2, 0. Uh-oh, that works out kind of terrible. Not terrible, but not helpful. So the vertex is right on the axis. And then we have the y-intercept. And if you remember, the y-intercept is the c number. So the y-intercept is -4. So that means my graph crosses down here. I don't know. Scroll down. Scroll down. Sam, do you remember how we found a third point? Because kind of so far what we usually do is just kind of find the easy spots and then do their mirror images. How do we find a third point? Or a next point? How do we find the next spot to graph? Usually we found one in between these two or one farther away. Second what? If you don't know, that's okay too, Sam. I was just trying to... what did I say second? I'll be honest, I didn't pay attention to what I was saying. I was just... Yes. Okay. So you're going to kind of pick a random number. I would recommend picking 1 or -1 just because they're easy to use. Okay, I would have picked -1 as well because it's going to be like a smaller answer. It's going to be over here somewhere. Okay, so random point. Good job, Sam. Thank you. So we're choosing -1. So that means I'm going to plug -1 into place of x. And that gives me -1 plus 4 minus 4. -1. So it's the point -1, -1. And then I'm going to draw its mirror image. Taylor, you are last on the list alphabetically, apparently, by first names. Do you remember what we were trying to find as the answer in the first place? What were we trying to find as the answer at the beginning of the problem? Like this. Why did we graph it? Do you want me to scroll up to the last problem? Okay. So on the last problem, we graphed it because we wanted to know where it crossed the x-axis, because those are going to be the solutions. So on this one, to solve it, we graphed it to find where it crosses the x-axis for solutions. Where does this one cross? It's 2, but yes, that's perfect. Yeah, it's terrible to read. I get it. Right there, at that one spot, and it's only one number this time. So that's the only solution. Perfect, thank you. Okay, so we have 15 minutes left. I want to show you a third thing that can happen, but we're not going to go through the work of graphing it. Like, we're not going to go through the work of doing it a lot. I want to show you a third possibility. So I just showed you that we can have 2 answers. We could have 1 answer. And then the third possibility is, it is entirely possible you won't have any answers. If I graphed x squared plus 3, it would look like this. And it would never touch the x-axis. So this one would have no solutions. So this section, the information given to you, I don't really want to call it short. That was a lot of writing. It's just this one topic, though. So it's not a ton of new information being thrown at you. And so that's why I kind of thought our goal would be to do the homework before lunch. Here, I can write the numbers up on the screen for you. And it's just a handful of them. And I'm going to cut out some of them even. 2, 4, 5, 6. Because it does take some time to graph them. I mean, like, that's for certain. And so you guys only have 4 questions to do. Your goal is to get those done before lunch. You got 13 minutes until lunch. Just leave your cameras and everything on here. And then when you guys go to lunch, we can shut them off and come back afterwards.